Hello, today we're going to go through a brief introduction on my book of airfoil vector formats. The contents include a brief 20-page write-up about the main issues with existing DAT files, how the format itself works, including 3 different methods to import the curve to whatever design software or environment you're using, 2 of them being algorithmic and 1 being formulaic. The book also goes over how to use the format in CAD software, as well as how to use things like chord and trailing edge thickness to make sure that you're getting the airfoil you want in the end. The airfoil library actually begins on page 21 or 23, and it goes over all of the general qualities of the airfoil, including thickness, camber, error from the original coordinates, in max and minimum, and the thicknesses also include their position in X. So for example, this airfoil has an 8% thickness at 17% of the chord, and obviously the airfoil name's included at the top. So what the graph displays, these red dots, are the original coordinates from the Illinois Airfoil or Airfoil Tools database, but they've been in some cases reference framed on 0 and 1 in the cases where they're off. So this library will provide a uniform reference frame in that respect. The blue spline or line that you see here is actually the spline formed by the format. So because the spline is actually a line, you can ask for as many coordinates out of it as you want. And you can see down here, for example, that we have 101 for every airfoil in the library. The dotted lines are actually displaying the spline control points. So when you use the system, these will have a kind of quality of their own, and you'll be able to recognize if your input coordinates down here are right. So these are the X spline and Y spline vector coordinates, and they're contained in the first 2 columns of this table, as well as an array down here which is easily copyable and exported from the book directly into whatever kind of tools designed to handle the format. So the book itself goes from page 21 in alphabetical order through all the airfoils that you could possibly want, at least 99% of them, down to page 1600. And this is actually an index of all of the airfoils that are in the book. This is image based, so you can use a search without getting double results from the index. And every page from 23 to 1599 looks pretty much the same except for the airfoil. So a good way to use the book is actually to search. For example, you could find a Clark Y pretty easily. It's kind of referenced in the write-up, so there are a few results, but it's very functional for looking up specific airfoils. If you have trouble looking for something like an Epler airfoil, it's usually denoted with a 3, with a E. But if you're having trouble finding any airfoils, then the index works very well to find related or slightly misnamed pages. And the real benefit is in looking up thicknesses like 10%. So in this case, we get all the results on the right here of airfoils that have a 10% thickness to chord ratio. And you can simply just scroll through all the options. So this is a great help when you're looking for options to include in your design. And this is also functional for camber. So if I want to have something with a camber of 3%, then I can do that and go through all the results here. It's even functional enough to go by just 3.1%. So it's just doing a text search through the whole book for pages with camber of 3.1%. So this is just a short overview, and I'll be going over more tools that use this language soon. But thanks for watching, and we'll talk later. Bye.